Lesson 5 is percent change, which means percent increase and percent decrease. These are problems that you're probably familiar with. You've probably tackled these before. But it is important. I want to spend the day on them because although there's a lot of problems that really are kind of straightforward, there's also a lot of problems that can trick you. And we don't want to get tricked. We want to try to not get tricked anymore. So let's take a close look at percent change problems. Now, in order to take a really close look, first I'm just going to look at change, without talking about percents at all, just to kind of set ourselves up for what follows. So change without percents, what would you say? I would say something like this. You usually start at some amount, starting amount. I guess maybe I'll put the word amount in. I don't want to just say start, right? So they have a starting amount, and then you change. You could add or you could subtract. You could go up or you could go down. So the starting amount plus or minus the change gets you to the end amount, right? I mean, I think that's kind of straightforward, right? You start, you change, and then you end at something different, right? So watch how these equations kind of come together, or watch how these, how this comes together as little equations here. Population of East Muckwick. It was 420. It increased by 20. What is it now? Okay, so reading is a big part of math, so make sure you're reading the words correctly. Was 420 is telling you that that's what you used to be. That's what you started at. So you started at 420. Increased means you went up. By 20 means the change is 20. And so the end amount is, well, I guess we could call it an x if we're building an equation, because that's the thing we're solving for. What is it now? Of course, it's not a hard equation to solve. 420 plus 20 is, well, it's 440 right now. Wasn't that slick? That was slick, right? Slick. Here's another one. So in other words, there's basically 3 situations we're going to face. So let's just take a quick look at all 3 of them. That's one of them. That's another one. Population of West Muckwick. It grew from 340 to 440. So how much did it increase? Well, I'm going to use the same formula. I'm going to say, what did I start at? Well, I started at 340. What did I change by? Well, I know I increased, but what did I change by? Well, I'm just going to call that x for now, because what I'm trying to do is I just want to hang things on the equation. That's what I'm sort of modeling or practicing right now. So 340 plus something, and it became 450. So that would be the new amount, the ending amount, the 450. That's a nice equation, right? And then you know how to solve that one, right? You do the old subtract 340 on both sides trick, and of course you're going to get it went up by 110. Maybe I'll just be official and say subtract 340 on both sides, and you end up with 110. Cool. So that's a second sort of, let's see, prototype isn't quite the word I want, but the second sort of like model example or whatever. And then here's another one that we can have. And this one's the one that tricks people usually, so let's be careful. The population of North Muckwick, it grew by 80. Okay, it's now 5,000. What was it before? So back to our formula up here. What did we start at? We don't know. That's where the x goes. Okay. Now in this case it grew, so again we add. It grew by 80, so the 80 goes there. It ends at 5,000. So there's what your formula looks like. Okay, so there's only 3 things to plug in, but if you don't plug them in the right places, you're going to be bummed. So we started at, don't know, x. We started at, don't know, x. Okay, and we then went up by 80s, and we ended up at 5,000. So where are we now? This equation you solve kind of like the last one. It's the old subtract 80 on both sides trick, and so x ends up being, what is that, 4,920, I reckon. Okay, that's the basic structure. Hopefully that's, something you can embrace, something you can groove on. Because now we're going to do kind of the same thing, except let's bring in this whole percent thing. How does the percent thing change that equation? It changes it this way. You'll have your starting amount. Yes, you will. And then you will either go up or down, increase or decrease. And then you will have, the amount of your change. And after you change, you can figure out what is your end amount, your ending amount. What did I call it up here? End amount. Do you see how that's different? start amount plus or minus the change is the end amount. See how that compares to this one? It's very different, right? No, it ain't. What's supposed to be different is that we're using percentages, and so how does that affect things? It affects things in, first of all, it affects things in a very different color. Okay, so it affects things as change. How should I put this? Where the amount of change is a percent of the starting amount. Oh wow, does the lesson from last time now seem to be ringing a bell and making sense? Look at that. Look at that. The amount of change is means equals percentage, make it a decimal, of means times the starting amount. Now the key here, and this is the part that can trick people, is it's always of. What are you? Go away. How do you go away? Go away? Okay. You always do the starting amount, the percentage of the starting amount, the starting amount, the percentage of the starting amount. Why is this guy singing? Why is he being weird? For me, that's how I always drilled things in. I made a little song, a little jingle, and then I could remember on the test or whatever I could remember. Anyway, hopefully you'll remember that. So that's what's new here. That's what's new here, is that the change we're going to express using percents. So it's still the same idea. The starting amount plus or minus the change is the ending amount. It's just that the change is going to be written as a percentage of the starting amount. Okay, let's see how this looks in practice. Back to blue. So what do I got here? The population of South Bend was 420. So that's the starting amount. I'm going to start writing that down, 420. It grew, oh, I went up by, okay, they're saying it grew by 20%. Not by 20, by 20%. So looking again at this part, okay, 20% of the starting amount will be, make it a decimal, and multiply by the starting amount, okay? And then that will be the ending amount, which is what we're solving for, so that's our x. Okay, so when we say it grew by 20%, it always means 20% of what we started at, and we started at 420. So this one you can kind of get out your calculator and just fly. So here I go, I'm flying, guys, I'm flying. I take the 420, I hit the plus, I hit the 0.2, I hit the times, I hit the 420 again, I hit the equals, pardon me, and I also got a 504. It was 420, it went up to 504. Okay, cool. That's one problem. Here's the problem type 2. The population, it grew from 340 to 550. By what percent did it grow? Okay, well, again, I'm always going to write this kind of an expression. I'm going to say, what did I start at? Oh, I started at 340. Woohoo, here I go. Now, by what percent did it grow? Uh-oh, we don't know the percent. We don't know the percent. But here's what we do know. Let's go for a new color here. Here's what we do know. The change is a percent of the starting amount, of the starting amount, of the starting amount. So that means that the percent, I don't know what the percent is, but it has to be multiplied by the starting amount. Get it? Get it? You multiply by the starting amount. This is a decimal, of course. In the equation, percents are decimals, but anyway, some decimal times 340, and that will be the ending amount, which is the 450 here. Okay, so there's your formula for this one. So how do you solve this one? Well, the first thing you have to do is you have to make room. So I'm going to lift that up. That's a little better. Okay, the next thing you have to do is you have to, you want to get x by itself. So there's my x term. So I'm going to actually subtract the 340 on both sides like this. So I've got 340x is what this term is. 450 take away 340 is 110. And notice what we're doing here. To get x by itself, I now have to cancel the 340 on both sides. So I basically divide both sides by 340. 110 divided by 340. What do we got here? 110 divided by 340 is 0.32, I'm going to round it a little bit, 0.324. Again, that's the decimal. The percent is, to go from a decimal to a percent, you go boom, boom, to the right 2 places. It's a 32.4% increase. Okay, so that's how you can do percent increase problems. Now, some people see shorter ways to do this. A shorter way to do this, maybe, if you don't mind, is to say, well, it increased by 110, and the percent is always of the starting amount. So you put the 110 over the starting amount. So some people, they start right here. They say, well, it went by 110. You know, they don't start here, they start over here. And you'll get the same answer, of course. Now, if you can see that and trust yourself and know in the very heart of hearts that that's the right way to do it, that's fine. But to make sure we never make a mistake, or at least to make sure that I never make a mistake, I'm going to keep doing it this way because this is the safe way. And I like the safe way. Safe ways are safe. I like that. Okay. And now for the one that can mess people up. Ready? The population of Not Bent grew by 80%, and it's now 5,000. What was it before? Okay. I'm doing the same thing again, right? I just told you I was going to keep doing it this way. So guess what? I'm going to keep doing it this way. I'm going to take the starting amount first. Okay, what's the starting amount? Population it grew by, it is now 5,000. What was it before? We don't know what it started at. X. We don't know what it started at. It does say it grew, so I'm going to add. And it says it grew by 80%, which always means 80% of what we started at. And notice that what we started at is we don't know. We have to use that X again, right there. 80% of what we started at. We don't know what we started at, so X is what we started at. So we started X, we grow by 80% of that number, 80% of that X, whatever the heck that X is, and we end up at 5,000. See how this is working here? We end up at 5,000. This is the safe way to fly. This is the safe way to fly. So how do we solve this equation? Well, first of all, you want to think of this as like a 1x plus a 0.8x. And if you add 1 plus 0.8 together, you get 1.8x. It's kind of like you have $1 and then 80 cents. You end up with $1.80. Okay, so just add, they're called like terms. They're both x terms. Just add them together. So 1x plus 0.8x is 1.8x. Okay, cool. And that equals 5,000. So in order to solve this, you want to cancel that off the x there. So you're taking the 5,000, you're dividing it by 1.8. So on the calculator, that looks like this. 5,000 divided by 1.8. And did I do this? I hope so. What I get? I got 27, if I round to the nearest person, 2778. Now, let me prove to you, or at least make it seem like the answer is reasonable. Okay? How do we check for reasonable? How about if I do that 10%, 1% reality check? If it was 2778, if it grew by 10%, it would grow by 277.8. Right? Remember the old to do 10% of anything, you just kind of slide the decimal back one because you're multiplying by 0.1. So 10% is 277.8, so that means 80% would be 8 times this number. So I'm going to go 8 times that number real quick. 277.8 times 8 is, and I'm getting 2222.4. So if it was 2778 and it grew by 2222, guess what? It ends up at 5,000. So the old 10% trick helped us prove that the answer is right. Okay, cool. Now here's what I really wanted to point out. Not just prove that the answer is right, but I said this one traps a lot of people. How do they get trapped on this one? Here's where they mess up. Here's where people can mess up, and this happens actually quite a lot, actually. So don't let this be you. Is they go too fast. That's always the problem. That's how you make mistakes in math. You go too fast. You fly without thinking so much. So if you fly without thinking so much, you'll say, hey, 80%. I know how to do percent problems. You make that a 0.8. Okay, I need a number. I need to multiply 0.8 by something. I guess I'll multiply it by the 5,000. So if you do that, if you multiply 0.8 times the 5,000, that will get you 4,000. Okay, so if it grew by that much, it grew by 80%. That must mean it grew by 4,000. So it was 5. It ended up at I must just subtract the 4th. I must have started at 1,000, right? Because 80% of 5,000 is 4,000. It grew by 4,000. So if it ended up at 5,000, it must have started at 1,000, right? do you see how like different those two numbers are? They're not just a little different. Those are like freaking different, right? Freaking different. So just be careful. You don't want to flyer. I'm not going to give partial credit if you do that. If you go 0.8 times 5,000, I'm like, okay, this person's not listening to me at all, and you're not going to get partial credit. So don't do it that way, please. Don't do it that way. Do it the nice and safe way. That's the best way to do it. The nice and safe way. Okay, so now we know how to do the percent increase problems. All percent increase problems can be written in this kind of a way. So let's do some actual like word problems, story problems, whatever you want to call it, real life applications. Taxes. Now, what gets more real life than that, right? 20% of Biff's gross pay is withheld for taxes. If his net pay after taxes is this much, what was his gross pay? Okay, I want to phrase this as an increase-decrease problem. Now, if they're taking taxes out of you, that means your pay is going down, right? So you start at your gross pay. That's the gross pay is the before taxes. So you start with a certain gross pay. You subtract the tax, and you end up with your what's called the net pay. It says it right here. Net pay is after taxes. You end up with your net pay. Now the tax is a percent of the gross pay. So 20% of his gross pay is held for taxes. We know what his net pay is. Okay, so the $742.54 is going over here. That's his net pay. What is his gross pay? So we don't know his gross pay. We're going to subtract the tax. And then how much is tax? 20% of what it was. 20% of this number. So 0.20x. So you had your you were thinking you were going to have your gross pay, but no, they're going to take away 20%. So they take away 20% of that. So again, the of what you started with, and that ends up at 742.54. Okay, so that's your proper setup for this problem. Solving it is going to go like this. First of all, that's like a 1x take away a 0.2x. That's like a dollar take away 20 cents. That's 80 cents. You get 0.8x. Over here, you've still got the 742.54. So to get x by itself, we need to divide both sides by the 0.8. So if you take the 742 and you divide it by the 0.8, you get, hey, what do I get? You get, what? I didn't solve it? Okay, I'll solve it now then. So I get the 742.54, boom, 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 divide by the 0.8, boom, boom, equals the boom. I got a 928, like maybe 18 cents. $928.18. So we got $928.18, but then they took away 20%, and so we ended up with the 742. This is, again, the important part right here. So again, if you're going too fast, you might say, oh, 20%, let me multiply 20% by this. If you multiply 20% by this and subtract or add or something, it's not going to work. Try it if you don't believe me, it's not going to work. And it's because the 20% is not supposed to multiply this, it's supposed to multiply this, okay? So it makes a big difference what you multiply the 0.2 by, is I guess the bottom line. What do we got here? Tipping. That's kind of like a tax almost. I mean, mathematically, it's the same structure as tax. No, it's not. It's like adding tax. It's not like income tax. It's like sales tax, I guess. So anyway, Biff's at a restaurant. He wishes to pay the bill plus a 20% tip. In other words, the bill is, you know, the little slip of paper they hand you that says pay this much, and then he's going to add a tip onto that and pay actually more than what the bill was, right? That's the idea of tipping. You're going to pay more than what they ask. So anywho, he's got 26 bucks to his name in his pocket. He lost his plastic, whatever. What is the highest that the bill can be before a tip? Okay. Let's be careful here. We're not going to run around. Hey. We're not going to run around multiplying 20% by 26. Multiplying 0.2 times 26, right? We're not going to do that. Now, what's the easiest way to explain to somebody that you don't do it that way? The way I explain it to myself is, hey, I'm going to tip 20%. And before I can figure out what the tip is, I have to know what the bill is because I want to take 20% of the bill. I don't want to take 20% of what's in my pocket. What if I happen to have a lot of money on me that day? What, am I going to just have to tip that much? No, that's not how you do it. You don't look in your pocket and say, I got 26 bucks, I'll tip 20% of that. No, you tip 20% of the bill. You wait for the bill. Okay, so that's my quick explanation of why you're not going to go 0.2 times 26. You're not, right? You're not. You're just not. What you're going to do is you're going to say, okay, let me write this as a percent increase decrease problem. In other words, we have the bill that's given to me, and then I'm going to add the tip, and the tip is going to be 20% of the bill. That's the tip, and that's going to be the total that I pay. Now, looking at the numbers up here, the $26 to his name, that's the total that he can pay. That has to go over here. What's the bill? We don't know. X. What's 20% of the bill? Well, it would be 0.20 times the bill, which is X. Okay? It's always 20% of what you started at. Always, always, always. So, I think we've solved this kind of equation a few times already, right? So you think of that as a 1x. These are called like terms. They're both x terms. You can just add them together. It's like taking $1 and adding 20 cents. You get $1.20 x, and that's equal to 26. So in order to solve, you take the 26, you divide by the 1.2, and I guess I didn't solve it because something was wrong when I wrote that, I guess. 26 divided by 1.2, I'm getting that the bill can be just about $21.67, something like that. That's how you do these. Okay, what else we got here? We got global warming. Okay. Due to global warming, it snowed 115% more this year than last year. By the way, you know how the ice caps are receding? Yeah. They're receding on Mars. I found that out and I went, what? They're receding on Mars. So what's that mean? I don't know. I guess we polluted Mars with our Viking rover. But anyway, I digress. So due to global warming, here's the phrase, it snowed 115% more this year than last year. Now, they give us some numbers to play with, but before we play with the numbers, let's make sure we've got the phrasing right. What's going on here? We had it snowed last year. Maybe I'll put last year's snow. And then it snowed more this year, so we're going to add some up to get to this year's total snowfall. Snowfall sounds a little more better, doesn't it? So, and this is a percent of last year's, right? That's how these percent changes work. It's a certain percentage of what you started at. It's always of what you started at. So anyway, can we hang some numbers on this now? We can hang the 14.4 inches last year. Oh, good, that goes over here. I always like it when it goes over here. Now, when they say 115% more, that means more means you're adding on. You're adding on what? You're adding on 115%, which is 1.5 of what you were, 14.5, right? And then you can solve for this year's snowfall. So that kind of comes together, I guess. You started at 14.5, you added 115% of 14.5. Where are we? 14.5 plus 1.15 times 14.5. Right? Right. So I'm up to something like 31.2 inches this year. Ooh, that is an increase, isn't it? Sort of as a little reality check, right? 100%, up 100% would mean double it. Because if you started at 14.5 and then you went up by 100%, that means you went up by as much as you used to have. You went up by the same. That would have been 29, and we went up by a little more than 100%, so we got a little more than 31, so it checks. It checks. So let's just get this out of the way. Okay. Let's look at another one. Yeah, it occurs to me, you know what, maybe I should leave that there, just in case somebody just... Yeah, I'll leave it like that. just in case people are just looking at what's written on the slide and they're not listening. So 100% of 14.5 is 14.5. So if you increase by 100%, that means you're adding the 14.5 to a 14. You end up with 29, and that says the word so. This checks out. Okay, that checks out. That's all I'm saying there. It's my reality check. Let's tackle another one of these. Global warming. It's saying the same thing. This year's snowfall was 115% of last year's. Is it saying the same thing? Hang on now. Hang on now. Look what this said. Be very careful about this. Reading is you got to read closely when you're doing any kind of math stuff. Reading closely is half the battle. This says it snowed 115% more. This does not say that. This says 115% of. Ooh, very different. It was 150% of last year's. Here's a phrase that I'm going to interpret directly. This year's snowfall, which they're not telling us, they're asking us, was or is 115% of last year's. This is a completely different setup. So you want to be aware of this, right? You got to read like oh so carefully. So 115% of last year's means 1.15 times last year's, just like this. And it says that is this year's. It is the answer. So there's none of this adding, there's none of this adding, you know, that doesn't work for this problem because that's not the way they phrased it. So just be careful out there. That's all I'm saying. So let's solve this thing now. Well, actually, that's not going to take long. So you take 1.15 and you multiply it by the 14.5 and bada boom, you got 16.7. Something like that. So, yeah, so it's when you say it's 115%, it means, remember, 100% would mean it snowed the same. So if you got 115%, that means it's like 15% more. It's just a bit more. So 14.5, it's just a bit more. It's 16.7. So there, it's working. Okay, one more. You might want to just pause and try this one yourself as a little self-check, self-test. You know, that's actually the best way you learn things is you just keep testing yourself over and over and over. You keep asking yourself, can I do this? Can I do this? Can I do this? And the thing with that is you can't answer it by saying, yeah, I'm pretty sure I could do that. You actually have to try it. You have to try it because you don't know until you try it whether there's any little point anywhere in the process where you might get stuck or make a mistake. So you really do have to, it's the best idea in the world. Stop, try it, see what you get. Okay, let's see what you got. Let's see what I'm going to get. Okay, let's see here. Due to global warming, this year's snowfall was 115% of last year's. Oh, so this is not an increase-decrease problem. Once again, you got to watch out for that of thing. This year's was 150% of last year's. Okay, cool. Okay, cool. So I'm going to actually write that here. This year's is 115% of last year's. Cool. It snowed 15.5 inches this year. How much did it snow last year? So 1.15 of last year. We don't know last year. So this becomes the decimal 1.5. This becomes a multiplication. Last year's is my x. Was is the same as equal. Look at how this problem sets up. So this is 14.5 divided by 1.15. And so what do we end up with? We ended up with, let's see now here, 14.5 is being divided by 1.15. And we's got 12.6. Maybe 6.1 if you want to try to be a little more accurate. Something like 12.6 inches was last year. So this year was 115% of this. Now again, 100% would be 12.6. If you want to add 15%, it means you add a little bit, you get to 14.5. So it seems reasonable. Okay, cool. So that was a little tricky. That wasn't a percent increase-decrease problem. Well, we know how to do the percent increase-decrease problems. You do them this way. You add a percent of what you started with. last year's plus a certain percent of last year's is always how these things work. Always how these things work. The bill plus 20% of what the bill was. It's always how these things work. The gross pay minus a certain percentage of what the gross pay was. It's always how these things work. So I hope you're hip to that pattern. I think we can end here. But yeah, let's do that.